There is a storm in our solar system so vast it could swallow our planet whole. Not just once, but multiple times over. This isn't science fiction. It's a real weather event, a hurricane of immense scale that has been raging for centuries. Imagine every hurricane ever recorded on Earth, every gust of wind, every drop of rain, all combined into one single colossal storm. Even then, you would not come close to the sheer power of this behemoth. It is a testament to the violent, chaotic, and beautiful forces that shape the worlds beyond our own. A constant reminder that our terrestrial experience is but a tiny fraction of what the cosmos has to offer. This cosmic tempest churns in the skies of a giant. It is a permanent feature, a swirling vortex that has been observed by astronomers for hundreds of years. Unlike storms on Earth, which are born over water and die over land, this one has no solid ground to stop it. It is a self-sustaining engine of atmospheric fury, a high-pressure system trapped in a world made almost entirely of gas. Its persistence challenges our understanding of weather itself. It forces us to ask new questions about how planets work, what drives their atmospheres, how long such incredible displays of energy can truly last. The universe, it seems, has a flair for the dramatic. We call it the Great Red Spot. It is the most famous storm in the entire solar system, a landmark on the face of the gas giant Jupiter. For as long as we have had telescopes powerful enough to see it, it has been there, a baleful red eye staring back at us from across the vastness of space. It is a place of incredible violence, with winds faster than anything we could ever endure. Yet, it is also a place of profound mystery. Scientists are still working to understand its secrets, to peel back its cloudy layers and discover what truly powers this ancient, world-eating storm. It's a puzzle written in the clouds of another world. The very idea of such a storm is humbling. It reminds us of the sheer scale of the universe. Our entire world, with all its mountains, oceans, continents, could be dropped into this storm and disappear without a trace. It is a force of nature on a level that is almost impossible for us to comprehend fully. And yet, we can study it. We can send our robotic emissaries across hundreds of millions of miles to get a closer look. So, what exactly is the Great Red Spot? In the simplest terms, it is a giant spinning storm in Jupiter's southern hemisphere. Think of it as a hurricane, on a planetary scale, but with a few key differences. On Earth, hurricanes are low-pressure systems. They spin around a calm center, the eye. The Great Red Spot, however, is an anticyclone. That means high pressure at the center. The gas in the center is at higher pressure than the surrounding gas. Earth hurricane, low pressure, or Great Red Spot, high pressure anticyclone. That pressure difference powers its immense size and longevity. The structure of the storm is fascinating. The outer edges are a maelstrom, with winds screaming at incredible speeds. The very center, though, is thought to be relatively calm, like the eye of a terrestrial hurricane, a pocket of stability in chaos. The storm spins counterclockwise. It's a self-contained vortex that steers nearby clouds and storms. It's not just a storm, it helps define Jupiter's atmosphere. Unlike Earth storms, the Great Red Spot has no solid surface to hit. Earth hurricanes form over warm ocean waters. They lose energy when they make landfall. Friction with land breaks them apart. Jupiter is a gas giant. It has no solid surface deep beneath its clouds. So the storm can rage on, uninterrupted, for incredibly long periods. It's born from the planet's internal heat. It's born from Jupiter's rapid rotation. And it has no natural enemy to slow it down. A perfect storm in a perfect environment for survival. Our weather is fleeting. On Earth, a storm lasts days or maybe a week. The Great Red Spot is semi-permanent. It's been churning for at least 400 years. To truly appreciate the Great Red Spot, we need to talk about its size. It is, to put it mildly, gargantuan. For a long time, the storm was wide enough to fit 3 Earths side by side within its boundaries. Visual size comparison. Earth fitting comfortably inside the Great Red Spot. Imagine that. Our entire world, every person, every city, every continent could fit inside this single storm with room to spare. Although it has been shrinking in recent decades, it is still mind-bogglingly large. Today, it remains wider than our planet. If you were to place Earth next to it, our world would look like a small marble next to a giant swirling bowling ball. The scale is almost beyond human intuition. The diameter of the Great Red Spot is currently about 10,000 miles, 16,000 kilometers. That is more than the distance from New York to Sydney. This isn't just a storm. It's a continent-sized vortex of swirling gas. If the size of the Great Red Spot is hard to comprehend, its wind speeds are even more so. The winds on the outer edge of the storm are unbelievably fast. Spacecraft measurements have clocked them at more than 400 miles per hour, about 640 kilometers per hour. To put that into perspective, Category 5 storms have winds of 157 miles per hour or more. The winds in Jupiter's superstorm are more than twice as fast as Earth's most violent weather, faster than a commercial jetliner. These are not just brief gusts. These are sustained winds, a relentless torrent of atmospheric gas. This is what you get when you combine a massive planet, a rapid rotation, Jupiter spins once every 10 hours, and a deep, hot interior. The planet's fast spin creates powerful jet streams. The Great Red Spot is caught between two of them, flowing in opposite directions. One jet stream flows westward, just above the storm. Another flows eastward, just below it. This shear helps keep the storm spinning, like a paddle wheel turned by two powerful currents. Imagine trying to stand in a wind like that. You couldn't. Nothing on Earth is built to withstand such forces. These winds would tear buildings from their foundations and send them flying like pebbles. The energy in this single storm is staggering. Scientists estimate the kinetic energy of these winds is many times greater than the total energy of all the nuclear weapons on Earth combined. It is an enormous amount of power, concentrated in one swirling region of a distant planet's atmosphere. But where does all this energy come from? Unlike Earth's hurricanes, fueled by warm surface water, the Great Red Spot is likely powered from below. Jupiter radiates more heat from its interior than it receives from the distant sun. Scientists believe that internal heat, rising through the atmosphere, acts as the storm's engine. It also feeds on smaller storms, merging with and absorbing them, adding energy to the system. It is a storm that eats other storms to stay alive, a true cannibal of the Jovian skies. The Great Red Spot redefines what a storm can be. One of the most iconic and mysterious features of the Great Red Spot is, of course, its color. Why is it red? The simple and perhaps frustrating answer is that nobody knows for sure. The rest of Jupiter's clouds are mostly shades of white, yellow, orange, brown. But the Great Red Spot stands out with its distinct reddish brick-like hue. This color has deepened and faded over the centuries, adding another layer to the puzzle. Scientists have several competing theories, but none have been definitively proven. The storm's color remains one of its most enduring secrets. One leading hypothesis suggests that the storm's powerful currents dredge up materials from deep within Jupiter's atmosphere. These unknown chemical compounds, called chromophores, color bearers, are then lifted to the upper cloud decks. Once there, they are exposed to harsh ultraviolet radiation from the sun. This solar radiation could, trigger chemical reactions that turn these compounds red. The specific chemicals are still a mystery. They could be complex sulfur, phosphorus, carbon-based compounds. Another idea is a reaction involving ammonia, acetylene. Laboratory experiments show these chemicals, when hit with ultraviolet light, can produce a reddish substance. The Great Red Spot's high altitude and powerful updrafts could provide the perfect conditions for this process on a massive scale. The storm's clouds are higher and colder than the surrounding clouds, which might concentrate reactions and give the storm its signature color. It could be a unique chemical factory in the sky. As we continue to study this magnificent storm, we hope to find the answers. And this is a perfect time to ask for your support. Please take a moment to subscribe to our channel. Like, share, comment with your theories. Your engagement helps us continue to bring the wonders of space right to you. Now, back to the giant. Why has the Great Red Spot lasted for so long? While its size, Jupiter's lack of a solid surface, another crucial reason is its diet. The Great Red Spot is not an isolated system. It exists within a dynamic, chaotic atmosphere filled with countless other smaller storms' vortices. The jet streams that border the storm constantly churning up smaller eddies. Many of these smaller storms get swept up by the Great Red Spot's immense gravitational pull and are, for lack of a better word, eaten. It is a cosmic predator, feeding on the chaos around it. Observations from spacecraft have shown this process in action. We have seen smaller, white-colored anticyclones approach the Great Red Spot, circle it a few times, and then merge with it. As they are absorbed, their energy and momentum are transferred to the larger storm. This process acts like a fuel source, helping to counteract the slow dissipation of energy that would otherwise cause the storm to spin down and fade away. The Great Red Spot survives because it consumes its neighbors. It is a beautiful and brutal example of survival of the fittest on a planetary scale. This feeding mechanism helps to explain the storm's incredible resilience. While any storm must lose energy over time through radiation and friction with the surrounding atmosphere, the Great Red Spot has found a way to replenish its strength. It is a delicate balance. The storm must be powerful enough to capture smaller vortices, absorb smaller vortices, but not so unstable that the mergers tear it apart. For centuries, it has maintained this balance, reigning as the undisputed king of Jupiter's atmospheric jungle, a testament to the complex dynamics that govern gas giant weather. This process also highlights how different Jupiter's atmosphere is from our own. Much of what we know about the Great Red Spot comes from a series of daring robotic missions. We have not been content to simply watch this storm from afar. We have sent our technological eyes and ears across the solar system to get an up-close look. The first detailed images came from Voyager 1, Voyager 2 in 1979. Their flybys provided the first movies of the storm, showing its swirling motion and showing interactions with smaller storms. For the first time, we saw the Great Red Spot not as a static feature, but as a dynamic, living weather system. In the 1990s, the Galileo spacecraft went a step further. It became the first orbiter of Jupiter, circling the giant planet for nearly 8 years. Galileo provided long-term monitoring of the storm, revealing its temperature, revealing its cloud structure, revealing wind speeds. It even dropped a probe into Jupiter's atmosphere. The probe gave us our first direct measurements of conditions inside the planet. Galileo's data confirmed the storm's roots run deep, and that it is a place of incredible atmospheric upheaval, a truly three-dimensional giant. Today, our primary eye on Jupiter is the Juno mission. Arriving in 2016, Juno is designed to study Jupiter's interior, Jupiter's magnetic field, and Jupiter's deep atmosphere. It flies in a highly elliptical orbit that skims above the cloud tops, closer than any mission before it. During these close passes, its instruments peer deep beneath the Great Red Spot. Juno's microwave radiometer gave us the first glimpse of the storm's deep structure, suggesting its roots may extend 200 miles, about 320 kilometers or more into the atmosphere, far deeper than scientists had expected. These missions represent humanity's relentless curiosity. We see a mystery, a giant red storm on a distant world, and we are not satisfied until we have sent our best technology to investigate it. Each mission built on the last, peeling back the layers of the Great Red Spot one by one. Voyager's first close-ups, Galileo's long-term watch, Juno's deep dives transformed the storm from a telescopic smudge into a complex object of study. And with each new discovery, the mystery only deepens, inviting us to look even closer. For all its power and longevity, the Great Red Spot is not immortal. One of the most surprising discoveries of recent decades is that the storm is shrinking. When astronomers began making reliable measurements in the late 1800s, the storm was estimated to be about 25,000 miles, 40,000 kilometers, across, wide enough to fit 3 Earths. By the time Voyager flew past in 1979, it had shrunk to about 14,500 miles, large enough for 2 Earths. Today, as measured by the Hubble Space Telescope and the Juno mission, it is only about 10,000 miles across. It is now only slightly wider than one Earth. The storm is not just getting smaller in width, its shape is also changing. It is becoming less of an oval and more circular. At the same time, some observations suggest that it is growing taller in altitude. It is as if the storm is being squeezed, forced to conserve its momentum by spinning faster and stretching vertically. The rate of shrinkage has also appeared to accelerate in recent years. This has led to a great deal of speculation and debate among scientists. Is the Great Red Spot dying? Will it disappear completely within our lifetimes? No one is certain what this shrinking means for the storm's future. Some models predict that, at its current rate of shrinkage, the Great Red Spot could become a Great Red Circle and then vanish within just a few decades. Other scientists are not so sure. They point out that the storm has likely waxed and waned in size over its long history, and this could just be a temporary phase. It is possible that the storm could stabilize at its current size or even begin to grow again if it encounters and absorbs a series of large, energy-rich, smaller storms. The fate of the Great Red Spot is one of the most exciting open questions in planetary science today. The Great Red Spot, as magnificent as it is not the only giant storm out there. Jupiter itself has other, smaller storms, a string of white ovals in its southern hemisphere, other, less persistent red spots that have appeared and disappeared over the years. Other gas giants in our solar system also have dramatic weather. Neptune has its own great dark spot, discovered by Voyager 2 in 1989, only to vanish by the time the Hubble Space Telescope looked for it a few years later. This shows even giant storms can be transient. As we look beyond our solar system to planets orbiting other stars, exoplanets, we are beginning to find evidence of even more extreme weather. Clouds of iron rain have been detected, winds that travel at supersonic speeds have been detected on hot Jupiters, gas giants orbiting incredibly close to their parent stars. The same laws of physics that create the Great Red Spot act across the galaxy, but under different conditions, they produce phenomena far stranger and more violent than anything in our cosmic backyard. Jupiter's storm is one example of the wild, wonderful world of cosmic meteorology. Studying the Great Red Spot is more than an academic exercise. It helps us understand fundamental principles of fluid dynamics and atmospheric science that govern all planets, including our own. By studying this extreme environment, we can test and refine models used to predict weather and climate on Earth. The universe is the ultimate laboratory. Jupiter's storm is one of its grandest experiments. It pushes the boundaries of our knowledge, forces us to think bigger, and imagine systems operating on scales of time and space far beyond everyday experience. The Great Red Spot remains an object of wonder and mystery. What gives it its color? Why is it shrinking? How much longer will it last? These are questions we're still working to answer. But the quest for those answers is what drives science forward. It is what sends us to the stars. The universe is full of wonders, waiting to be discovered. So keep looking up. Keep asking questions. Never lose your sense of curiosity. The cosmos is waiting for you. If you've enjoyed this journey, please subscribe and share. And join us again as we explore the next great wonder of the universe. It's older than the United States of America. It has outlasted empires. It has outlasted generations of human lives. It's less like a weather event and more like a geological feature on Jupiter, a living, breathing part of the planet's identity.